AI's energy appetite is already staggering, and projections suggest it could reshape global electricity demand within the next decade. Data centers consume less than 300 terawatt hours of electricity in 2020, but forecasts from the International Energy Agency indicate this could surge to nearly 1,000 terawatt hours by 2028, more than Japan's entire electricity consumption today. By 2028, AI workloads could account for nearly half of all global data center electricity use, with workloads growing at 30% annually compared to just 9% for conventional servers. Training advanced models like GPT-4 has already consumed over 50 gigawatt hours, enough to power San Francisco for 3 consecutive days. These figures highlight how AI's evolutionary cycle, from perceptive AI to generative, reasoning, and eventually physical AI, will demand exponentially more energy as applications expand into robotics, autonomous vehicles, and industrial automation. Future projections suggest AI could push electricity demand into unprecedented territory. Industry leaders warned that the rise of physical AI could drive demand even higher, potentially reaching 15% of total electricity consumption by 2030. In the US, utilities are producing forecasts that they may need 2 to 3 times more electricity within just a few years to power massive AI-driven data centers. This raises questions about infrastructure feasibility, as building new power plants at such speed may be impossible. While some researchers argue that AI's overall contribution to emissions may be smaller than feared, the local impact could be dramatic, doubling electricity output in certain regions. The paradox is clear. AI is both a voracious consumer of energy and a potential driver of innovation in renewable generation, smart grids, and fusion research. If AI evolves towards self-sustaining infinite engines, the challenge will be balancing its boundless demand with sustainable supply. Artificial intelligence is often described as a brain without a body, an entity that can think, calculate, and create at speeds far beyond human capacity. But behind every algorithm, every chatbot, and every generative model lies a hidden hunger: power. Not metaphorical power, but literal electricity. As AI advances, its appetite for energy grows exponentially, rivaling the consumption of entire industries. Imagine the paradox. A technology designed to transcend physical limits is tethered to the most physical of all constraints, the flow of electrons. Now picture this. What if AI could break free from those limits? What if the same systems demanding colossal amounts of energy became the architects of infinite supply? This episode begins with that tension, the collision between today's reality of massive data centers straining grids and tomorrow's speculative vision of AI-driven engines that generate boundless power. It's a story of paradox, possibility, and the profound question of whether intelligence itself can rewrite the rules of energy. The current landscape of AI power demands. AI's current power demands are reshaping the global energy landscape, with data centers emerging as one of the most energy-intensive infrastructures of our time. In the United States alone, data centers already account for about 5% of total electricity consumption, and projections suggest this figure could rise to 15% by 2028. These facilities are not only powering the training of massive AI models, but also the inference processes that make everyday tools like ChatGPT, recommendation engines, and autonomous systems functional. The clustering of data centers in regions such as Northern Virginia, Silicon Valley, and Dallas-Fort Worth has created localized grid pressures, forcing utilities to warn of annual demand growth rates exceeding 5% and the need for billions in infrastructure investment. The environmental footprint of AI-driven data centers extends beyond electricity into water and carbon emissions. A recent Cornell study found that by 2030, AI infrastructure could emit up to 45 million metric tons of CO2 annually, equivalent to adding 10 million cars to U.S. roadways. Cooling systems alone account for up to 40% of total energy use in data centers, while also consuming vast amounts of water. potentially draining 1,000 million cubic meters per year, equal to the household water usage of 8 million Americans. This dual strain on electricity and water resources highlights the urgency of sustainable innovation. Researchers point to solutions such as waste heat recovery, AI-powered grid optimization, and renewable energy integration as ways to mitigate the impact. Yet, the scale of demand is so immense that even small inefficiencies translate into massive environmental costs. The current landscape is therefore defined by a paradox. AI is both a driver of extraordinary technological progress and a source of unprecedented energy challenges, forcing governments, utilities, and tech companies to rethink how power is generated, distributed, and consumed. Beyond physical limits, the concept of infinite power. When we talk about AI's infinite engines, we're really exploring a provocative paradox: intelligence that consumes vast amounts of energy yet simultaneously holds the keys to unlocking new forms of generation. The idea of infinite power isn't literal. Physics reminds us that energy cannot be created from nothing, but it does capture the imagination of what AI could achieve when paired with advanced technologies. Consider fusion energy, often described as the holy grail of power generation. AI is already being used to model plasma behavior and optimize reactor conditions, potentially accelerating breakthroughs that could make fusion commercially viable. If successful, this would provide humanity with a virtually limitless supply of clean energy, and AI would be both the driver and the beneficiary of that revolution. Beyond fusion, AI's ability to orchestrate complex systems could redefine how we think about energy abundance. Smart grids, powered by predictive algorithms, can balance supply and demand in real time, reducing waste and maximizing efficiency. AI-driven materials science may uncover new superconductors or battery chemistries that radically expand storage capacity, making renewable energy sources like solar and wind effectively infinite in practical terms. Philosophically, the notion of infinite power challenges us to rethink scarcity. If intelligence can continuously optimize, recycle, and innovate, then the boundaries of energy availability shift dramatically. Yet this vision also raises profound questions. Who controls such abundance? How is it distributed? And what happens when a technology designed to transcend physical limits begins rewriting the rules of civilization itself? AI is an energy innovator. Artificial intelligence is not only a voracious consumer of electricity, it is also emerging as one of the most promising tools for transforming how energy is produced, distributed, and conserved. Across the globe, AI is being deployed to optimize renewable energy systems, from predicting solar and wind output with unprecedented accuracy to balancing supply and demand on smart grids in real time. By analyzing weather patterns, grid conditions, and consumption behaviors, AI can reduce inefficiencies that traditionally waste vast amounts of energy. For example, predictive algorithms allow utilities to anticipate surges in demand and reroute power accordingly, minimizing blackouts and cutting costs. In this way, AI is already acting as a catalyst for cleaner, more resilient energy infrastructures. Beyond optimization, AI is accelerating breakthroughs in entirely new forms of energy generation. In fusion research, machine learning models are helping scientists stabilize plasma reactions, one of the most complex challenges in physics, bringing humanity closer to unlocking a virtually limitless source of clean power. Similarly, AI-driven materials science is uncovering novel battery chemistries and superconductors that could revolutionize energy storage, making renewable sources far more reliable. These innovations suggest that AI's role in the energy sector may evolve from being a demanding consumer to becoming an architect of abundance. The irony is striking. The very systems that strain our grids today may ultimately design the technologies that free us from those constraints tomorrow. This dual identity, AI as both a burden and a liberator, positions it as one of the most transformative forces in the future of energy. Risks and ethical dimensions. The pursuit of infinite energy through AI raises profound risks that extend far beyond technical feasibility. At the most immediate level, the concentration of power, both electrical and institutional, creates vulnerabilities. If AI-driven systems were to control vast energy flows, the question becomes who owns and governs that infrastructure? A handful of corporations or governments could monopolize access, creating geopolitical imbalances and exacerbating inequality. This centralization of energy control could mirror the monopolistic tendencies already seen in digital platforms, but with far higher stakes, as energy is the lifeblood of modern civilization. The ethical dilemma lies in ensuring that abundance does not become a tool of exclusion where infinite power exists but is rationed or withheld for profit or political leverage. Environmental risks also loom large. Even if AI enables breakthroughs in renewable generation or fusion, the sheer scale of demand could still strain ecosystems. Data centers already consume massive amounts of water for cooling. An unchecked expansion could threaten local communities and biodiversity. There is also the danger of rebound effects as energy becomes more abundant. Consumption may rise unchecked, leading to new forms of waste and pollution. Ethically, this challenges us to ask whether infinite energy should be pursued without parallel commitments to sustainability and restraint. Finally, governance becomes critical. Who sets the rules for how AI interacts with energy systems, and how do we prevent misuse? Without transparent oversight, the same intelligence that promises liberation could be weaponized, destabilizing grids or amplifying cyber vulnerabilities. In short, the risks and ethical dimensions remind us that infinite power is not just a technical dream, but a societal responsibility demanding foresight, fairness, and global cooperation. Future scenarios. Imagine a world just a few decades from now where AI has become the architect of energy itself. In one scenario, vast networks of AI-managed fusion reactors hum quietly across continents, producing clean, virtually limitless power. Cities glow with uninterrupted electricity. Industries run without fear of shortages, and the concept of energy poverty becomes a relic of history. AI systems continuously optimize grids, recycling waste heat, balancing renewable inputs, and ensuring that every watt is used efficiently. In this utopian vision, abundance fuels innovation. Desalination plants provide fresh water to arid regions, vertical farms feed billions, and global cooperation thrives because energy scarcity no longer drives conflict. Humanity, guided by AI's infinite engines, enters a new era of prosperity. But there is another path. In a more dystopian scenario, the same abundance becomes a tool out of control. A handful of corporations or governments monopolize AI-driven energy systems, deciding who gets access and at what cost. Infinite power exists, but it is rationed, weaponized, or withheld, creating new forms of inequality. Regions without access to AI-managed grids fall behind, while those with it surge ahead, widening geopolitical divides. Environmental consequences also linger. Unchecked consumption leads to new forms of waste, and ecosystems strain under humanity's insatiable appetite. In this darker vision, AI's infinite engines do not liberate humanity, but instead entrench power structures, raising urgent questions about governance, ethics, and sustainability. Will AI's evolution toward boundless energy be a collective triumph, or will it deepen divides and create new risks? The answer depends not only on technological breakthroughs, but also on the choices societies make today about regulation, equity, and stewardship. The future of infinite engines is not predetermined. It is a narrative still being written. Episode closing takeaways. As we close this bonus episode, the central paradox becomes clear. Artificial intelligence is both one of the greatest consumers of energy in human history and one of the most promising innovators in how energy is created, managed, and sustained. Its evolutionary cycle from data-hungry models to potential architects of fusion breakthroughs forces us to confront the tension between scarcity and abundance. The idea of infinite engines is not about defying physics, but about reimagining what abundance could look like when intelligence is applied to the most fundamental resource of all, power. AI's trajectory suggests that the future of energy will not be defined solely by kilowatts and grids, but by how we choose to align intelligence with sustainability, equity, and governance. If AI's demand continues unchecked, we risk straining ecosystems, widening inequalities, and destabilizing infrastructures. But if its innovative potential is harnessed responsibly, AI could help unlock clean, abundant energy that reshapes economies and societies for the better. The challenge is not whether AI will consume or innovate, it will do both, but whether humanity can guide that duality toward outcomes that serve collective prosperity rather than concentrated power. In the end, the quest for boundless energy is less about machines and more about values, how we govern, distribute, and steward the infinite engines of tomorrow. Thank you for being part of the Digital Revolution community and for joining the series on this journey through the ever-changing world of digital innovation and revolution. Until next time, stay curious, stay inspired, and as always, keep pushing the boundaries of what's possible.